You know, it's radios like this that make you almost believe in conspiracy theories. I am not a conspiracy theorist. I don't believe little green men are taking people. You know, I don't believe the government is coming to get me in their black helicopters. But I'm here to tell you, when it comes to two-way radios, cheap two-way radios, so meaning CB radios and export radios, yes, you may think they're expensive, but honestly, in the grand scheme of things, they're cheap, disposable electronics. I swear, it is a conspiracy that's been around since, God, I don't know, I guess the 70s. And what that is, I don't want to say programmed in, but designed in obsolescence, or, you know, breakage, I guess you could say. And this one demonstrates that. So what is this? It's a Stryker... What the hell's the model number? I don't remember. It's an SR something. What the hell's the model? Well, that's right. It's on the meters on these. It's a SR-490. I don't work on many Strykers. Not a huge fan of them. But anyhow, this one was sent in because it stopped transmitting and receiving. Well, yeah and no. So, you know, first thing I did was, you know, pull the covers off, just a really quick look over. It has been worked on a few times previously. I guess at least twice. Maybe. There's one of Bob's stickers, and that's from 2015, so that's a couple years ago. I guess Bob worked on it. This radio is definitely, I looked at the semiconductors, but it's definitely before 2015. And there's a full tune there. Looks like back in, I guess, 2008. And I guess that's where it got worked on in 2015. But, not exactly sure what they had done to it. I'm assuming probably at one point it was peaked and tuned. I haven't even gotten that far yet. Though, I don't see any trimmer potentiometers cranked to full rotation, and it looks like maybe some modifications might have been removed. So, yeah, that's a good thing. There's a blob of solder on that resistor right there. That looks like that was put back in circuit, so it may have been demodified by Bob. So whoever did the original work on this thing, I guess back in, or at least a full tune in 2008, might have clipped something, and yeah, some of that stuff was undone. But in any case, one of the things I did notice was some of the corrosive glue had been removed out of that, and that's what I'm talking about. I got a conspiracy theory about this. I swear they put that shit in these radios so they break. It's not like these manufacturers don't know that glue over time gets hard, dark brown, brittle, conductive, and corrosive, and eats the radios from the inside out. It either causes physical damage or electrical damage at the very minimum to cause a radio to stop working. And this is a prime example of that. So like I say, there had been some glue removed from around those two crystals. I wasn't too sure about this once I actually pulled it out, and there was still glue on the underside of the crystal, because whoever cleaned that glue out didn't remove the crystal. And that's a word of advice when you're cleaning that corrosive glue out. If that stuff's all around the part, trust me, it oozed underneath of it. Unless you physically remove the part, desolder it off the board, scraping the glue off from around the outside isn't going to do you any good. That part's not touching the electrical connections, you know, the terminal leads. You need to remove the part to be able to clean the glue off on the board that's underneath of it, and clean the terminals off to get that stuff, more importantly, off of the terminals. So I did clean this crystal off. This one was fine. The glue hadn't oozed underneath of it. But after just some, like I say, quick inspections, it didn't look like there was any smoke had been let out. You know, the magic smoke hadn't escaped. I plugged it in and tried it, and this course does have it's a 10-meter radio, you know. It has the export modification done, which doesn't get much easier in these radios. All you got to do is move that jumper on the PLL the microprocessor channel selector board. But it was on the CB band, sure enough. Key the microphone, nothing, receive, dead. If you would go down in band, because this thing, I'm not even sure what the hell does it have. Of course, the faceplate's off. It's, what, 1, 2, 3, 4, 5, 6, 7. It's an 8-band radio, and band, I think it's D, is the CB band. From band D down, it was dead. Actually, it was dead on even F, which is up one band, until you got up fairly high in channels. When you get up around the 30-something range in channels, you key the mic and I'd see the power needle flicker. And the higher you went in band, eventually it had a steady output power, but then it would stop transmitting, and then it would transmit, and then it would stop again, and yeah, something's seriously wrong. So, you know, common things that can cause that in a radio where it just basically it's dead. The whole thing's dead. Radio's on, lights up, has intermittent. Now that was actually one good thing, because at least if it's transmitting and receiving, at least on some band, we know that pretty much that limits our area of concern to like right here in this area. It's not going to have anything to do with the receiver circuit, the transmit circuits, the audio circuits, even could be power supply, but doubtful. It's usually going to be isolated to your synthesizer oscillator circuits, so frequency generation within the radio. So crystals, oscillator circuits, PLL, your synthesizer, VCO circuit, all of that, and in this case of this radio also includes a microprocessor. So I did some really quick checks. I just probed at the crystals. I had they looked stable. The oscillator circuit, the crystals were running. Everything looked fine. Probed at the PLL, which is actually mounted on the back side of the board on these radios. That's one of the reasons I'm kind of about these Stryker radios. What a hodgepodgery of engineering or design. Who designed this thing? They made a hybrid through-hole surface mount abomination. I'm sorry, that's what it is. It's just, what the hell were they thinking? If you're going to go surface mount, go surface mount. I mean, Stryker has fully surface mounted radios, but with the exception of the normal components you'll see that are through hole, electrolytic capacitors, and CB radios at least in most cases, they don't use surface mount electrolytics. They'll still use through holes, but large inductors, the normal parts you'll still see through hole. But for the majority of stuff, if you're going to go surface mount, just do it. It's more reliable, it's cheaper, honestly, for the manufacturer, so I don't know why they don't do that. But in any case, so I come to the PLL chip. Now this is a programmable PLL chip. This is not your normal PLL like you would find in other radios where the channel selector, there's a bunch of input or program pins on your PLL, and your channel selector is just supplying either highs or lows in different combinations to make up the programming code, basically, for the input of that PLL, to tell it what channel to go to. This is not one of those. This is a programmable one, so this actually has a MC145162 in it. And you can see, depending on exactly which one you get, it's either a 60 or 85 megahertz universal programmable dual PLL frequency synthesizer. So this can actually, it's actually two PLL chips in one. Did some probing on that, and yeah, it just didn't look right. So the first thing is, these do not have that connection to the channel selector switch. They're programmed by a microprocessor that's down on the channel selector board. There's a board under here that has a bunch of ICs on it. And you can even look at the pinout and see that. You can see you have your clock, your oscillator, normal PLL things. You'll have your oscillators in and out, your voltage supplies and whatnot. But there's really only 4 connections from this board to the PLL to control it. But it's controlled digitally. It's programmed. It's actually programmed. So yeah, it's not looking right at this PLL. Could it be the PLL? Yeah, it's possible, but we want to dig a little bit further first, because there could be a problem with the microprocessor board. And sure enough, I pulled the face. Of course, you can't see anything on that. It's buried down in there because all the parts are on the bottom of the board. So it's sandwiched in just like that. That's about what you can see down through a little gap. So pull the faceplate off, pull this board out, and there it is. Corrosive conductive glue. Just look at that crap in there. Get zoomed in here a little bit. You see that brown nasty stuff? Yeah. Now when they put that, and there's more of it there, there's a piece of tape over, and that's all that stuff. But this stuff here is hard. It is dark brown, because of course these ICs get hot. And in my experience, that is what makes this stuff go bad. You know, when they first put it on there, it was fine at the factory. It's not corrosive and conductive when it's new, but you bake that stuff with the heat of, you know, components or just, you know, vehicle temperatures. If it's, you know, mounted in a vehicle over the years, it decomposes and becomes this nasty brown stuff that conducts electricity and is also corrosive. You know, this stuff over here, you can see that's still kind of flexible. Well, that's because it doesn't get hot over here. It's not on an integrated circuit that's getting, you know, that's generating heat. So I just checked that with an ohm meter. Let's see if I can get this. There. Just turn the meter on over here, and I'll just show you. And it depends exactly where you probe, but depending where I probe, has different resistances, but the glue is corrosive, and I'll show that. I'll put a lead on top of the IC package. So, you know, the plastic part, the part that definitely shouldn't be conductive, I'll touch the glue on the top of the IC, and then the other lead down to the glue where it's on the circuit board, and you'll see it's got continuity. That right there is a dead giveaway. Let's see, let me get my meter set up here. Utility, system, display, invert. Okay. Now you should be able to see the screen. God, heck. Let me move these covers out of the way. Trying to get this in camera view is, yeah, easier said than done. Almost need to put the radio right in front of the meter here. There we go. That's a little bit better. So now I'm doing this at arm's reach, so I can't even half see. So I'm going to touch this lead to the top of the IC, so I'm touching plastic there. Okay, I'll zoom in a little bit so you can see that. I'm on top of the IC, but there's glue there, and we're not going to move that lead. I'm going to touch the glue. Ah, it just slipped off. Let me get back on there again. Yeah, there's like 20, moved again. Come on. One of these ICs might have been this one. Yeah, there's like 11 meg. Now that's high resistance, but still, that's from the plastic top part of the IC down to the board. There should be no you know, electrical connection to the plastic package. Well, it's not that the plastic's conductive; it's that blasted glue. And if the closer you probe together with that stuff, of course, the lower the resistance is. So, and unfortunately, what makes it so bad with this one is they poured it on every single IC. Why? But what? Can you explain this to me? Other than that's my conspiracy. There's absolutely no reason at all to put glue on any of these parts. None. Surface mount parts are attached with the solder, okay, to the board. That's the way they're designed. That's designed. It'll hold it on there. They don't need help. They have to put that shit on there to cause problems. That's engineered obsolescence. Eventually, they know this shit's going to go corrosive and conductive and kill the radio. Why else would they do that? There's absolutely no other reason. I just, yeah, that's why I hate manufacturers, man. What were they thinking? I mean, just look at that crap. I don't know. So, yeah, and I don't know what's might be shorted out where. Maybe the V is underneath the here. It's not on the pins from the looks of it, at least. I'm assuming, well, you see, that's the thing. There's vias and there's other solder connections all around and underneath. So I'm going to have to remove all 4 of those eyes. Of course, I need to get the glue off over here too. But I'm going to have to remove all 4 of those surface mount ICs so I can properly clean it, because I guarantee you that glue has oozed just like it did the crystals on the top side of the board. It's oozed underneath of that IC, and I don't know which one of these see all these little tiny pass-through vias, all these little holes. Well, there's going to be a bunch of those underneath of these ICs, and that's probably what that glue is shorting out. And that's what's screwing up my data, you know, or my connection between the PLL and the microprocessor is that glue. It's just got this thing haywire. So, well, let me get to it. Like I say, I need to remove them, get all the crap cleaned off of it, reinstall all of the ICs, and see if she springs back to life. I got a pretty good feeling that's probably going to fix it. You know, so fingers crossed. But yeah, I mean, companies and their glue, you just, for God's, here's what pisses me off even more. Because I'll often say, you know, why don't they use something that's not going to become corrosive and conductive? Something like hot glue. We know they use it. What's that? This was done at the factory. Hot glue, hot glue, hot glue, hot glue. Turn the radio over. Hot glue. There's hot glue in the radio and other places. Why did they use corrosive crap on electrical connections and non-corrosive stuff on in other spots? Explain that one to me. Yeah, I have none. Other than it's a conspiracy, man. They're out to get you. They're out to kill your radios. So let me get to it, and we'll be back and see if we get this thing fixed up with just something. I'm not going to say as simple as removing the glue, because like I say, that's going to be a fair bit of work. But see if that's actually all that's wrong with it. It's just glue, possibly. So I'll be back. Oh, good Lord, what a pain in the butt. I didn't even think about it. Through-hole components on one side, surface mount parts on the other. I didn't even think about they're glued on. Yeah, this makes them real challenging to take off. So if you look, you can see the ICs are off. They're actually all laying right there. They've been cleaned up and ready to put back on. But man, getting them things off. What they do at when they're manufacturing boards, if they have surface mount parts on, so this side actually went through a solder bath, okay, or probably actually with solder paste, but still it was heated up. But this side of the board would have been facing down, so the parts don't fall off. What they do is, before the parts are installed, they apply dots of glue. And then it can go through the reflow oven, reheats the solder, and they don't have to worry about the parts falling off as it's going through the oven. The problem is, you know, years later, glue gets corrosive. Not this glue. This is proper electronics adhesive, not that crap that they're using. Yeah, and you can see this red stuff. Yeah, it's still fine, and probably 100 years from now, it'll still be red, and you know, it's almost impossible to get off because that is some nasty stuff. But that makes it really, really challenging getting ICs off. So if you ever have to do one of these, just be aware of that. You can have all the solder, all of the solder on all of the connections molten, and the IC is not going to come off. You're going to have to pry it off. If you're using thermal tweezers, or depending what tool you might be using, a lot of times a good sharp twist will snap the glue loose. You know, actually, like these two here, what you could do is stick maybe a small blade screwdriver in between, and once you get the solder molten on the one IC, you can just slightly twist your screwdriver just to get it to shear off. You know, it just try to get something up underneath of it, you have to pry up on it, but yeah, you're going to have to break the bond of that glue, so be aware of that. So I got it all cleaned up all the glue that was over here. Yeah, all of these connections were nasty looking. They actually might have been shorted together too. The glue on the top was fine, but the glue that was touching, yeah, it was hard as a rock too. But I've got all that cleaned off, board's prepped, so all I need to do now is stick the 4 ICs back on there and resolder them back on, stick the board in, and we'll see if it works. So, like I say, fingers crossed. Hopefully that does it. I don't think that would have been, I mean, they're going to be high resistance, could screw up, you know, obviously a short of any kind can screw up, especially a data line, but I seriously doubt there was anything enough that it would have damaged any of those ICs, so they should all still be fine, as long as we remove that, you know, basically high resistance short. Hopefully everything will come back to functioning order, so let's find out. Okay, so this thing is now fixed. It had other problems. So as you saw, cleaned all the corrosion off of the microprocessor channel selector board, reinstalled the ICs, cleaned all that up. I did miss something there, which was a problem I had to fix. Still did not have any VCO voltage. More troubleshooting. I found that the what the heck is it in this one? A 14.01 megahertz reference crystal oscillator circuit was not working. Remember I had said someone had cleaned the glue off from around these two crystals, Well, they didn't clean the glue off from around the crystal, the 14.01, that's down under here. That would be this one. And this is why I say you have to remove the crystals to clean the glue off. Where's the other lead? It's gone. Yeah, you can see the glue residue there. It ate it off. So that's why that that wasn't working. Fix that. Put in a new crystal. That allowed me to change channels, but the band selector switch was not working. So I couldn't switch bands. It was stuck in one band. So that took me back to the microprocessor channel selector board. There are 4 ICs on that board. One of them's a 74, God, I gotta look over here at the schematic. It's what, 165, I think. What is that? Yeah, 74HC165. That's used for input to the microprocessor, so it knows what position the band selector switch is in, because this is an 8-position switch. So that chip then sends the data for the position of this switch to the microprocessor, so it knows what band to put the radio in. You know, and then it sends the data down to the PLL to program the PLL chip. One thing I missed when I was cleaning up that board, I removed the corrosive glue off of it. That glue had actually eaten through a circuit trace. It had basically corroded through the trace that connects the data output off of the 74HC165 IC to the input of the PIC microcontroller that's in here. So it lost its data. So the microcontroller didn't know that the mode selector switch was being changed. So it was just stuck on band D, I guess it was. Yeah, it was stuck on band D. So I repaired that trace, cleaned it off, just bridged it with a small piece of a 30 gauge Kynar wire. Well, actually not Kynar wire, I stripped the insulation off, but just a little small piece of 30 gauge wire. Put the channel selector board back in again, and it works. So if you own one of these and you ever do lose receive and transmit, like I say, it's usually going to be isolated to basically this section here. Now you could have voltage, power supply problems, but if the radio turns on and you've got most of your power supply rails, so you've got your 13.8 coming in, you've got your 8-volt regulator circuits working, your problem's probably going to be in this little area right here. In any radio, at least CB radios, it can be a export radio or even just a normal FCC certified radio. Most radios have the PLL synthesizer circuit, especially more modern ones, in this area. Your problem's probably going to be there somewhere. First things to check are always going to be, if you have VCO voltage, does it change when you're changing channels? Or if it's a radio that has bands, you should see big voltage changes when you change bands. If you don't have VCO voltage, because it's a continuous loop, your synthesizer circuit, the phase lock loop. That's why the last word in PLL is loop, because that's what it is. It's a feedback circuit. It senses something's wrong, it makes a correction, so it's a continuous circle, that entire circuit. And if you break that circuit somewhere, it won't lock. So, like I say, this one had a couple problems. I think this was the main problem. Right here was the crystal. Like I say, no oscillator circuit. Yeah, it wasn't going to do anything. And I think actually where I had transmit power, I didn't check frequency or anything. I just noticed I had some intermittent transmit power in some of the higher bands. It was probably at some weird arbitrary frequency too. Or this may have been just barely making connection, because the lead, of course, was still sticking in the board. When I desoldered it, it sucked the lead out of the board. So it may have been just barely touching there. But yeah, it was actually corroded off. So between the crystal, cleaning all that glue off the microprocessor board, and then repairing a trace that it had actually eaten through, has fixed it up. So the only thing I realigned on this was the synthesizer circuit, because it was 2015. This thing was just at Bob CB, so I shouldn't have to go over the rest of the radio. Somebody else has already worked on this, and he didn't ask for an entire transceiver alignment. He sent the radio in for the complaint of no receive and no transmit. But yeah, so if you own one of these and it's working, I would probably recommend, like I said, I don't see a lot of Strykers, so I'm going to assume that's probably a common problem in these. And if it's not common yet, it's going to be the glue. So if you own one of these, I highly suggest pull the faceplate off, pull the front structure out here, pull your channel selector board out, clean the glue off. Even if you don't take the ICs off the board, there's 4 ICs, just get as much of that glue off of the microprocessor board as you can before it starts eating through the circuit traces. Also, remove your crystals, clean the glue off. Like I say, cleaning the glue off from around the outside of the crystal isn't going to do you any good. The glue that destroys the crystal is the glue that oozes up underneath, just like this one. You can see there wasn't any glue here, so it never touched this lead, so it never broke off. Where the glue oozed underneath on this side, it touched the lead and ate through it. So, very important, remove the glue. And if it hadn't been for the glue, this radio wouldn't have had problem. Like I say, that's my conspiracy theory. They put that crap in there on purpose for the radios to break, so you have to buy a new one. it just drives me nuts when I see that stuff. And just to make matters worse, they put it on the microprocessor board. What in God's name were they thinking when they did that? They've got glue on there that held the ICs on when it went through the reflow oven. Did they really think they needed additional glue? No. I can't think of any other reason why they'd have put that other glue on there other than to make sure that the radio failed at some point. It just, wow. I swear that's got to be pre-engineered. It just... So, there you go. There's an SR-490. Of course, I got to get it all put back together, but... that's what was wrong with it. So if you own one of these, you're having problems, first things to check. Check your crystals, check the microprocessor board for glue, clean it off. Inspect the microprocessor board really well to make sure it hasn't eaten through any of the circuit traces, and your crystals, that it hasn't eaten the leads off of any of them. If it's not that, well then you're going to have to do some other diagnostics. But yeah, I can see that being a common problem in these. Just looking at where that glue was, that's going to be, if you own one of these, it's going to happen eventually. That stuff's going to kill your radio.